Welcome everyone and good evening to this very special NSF NCAR Explorer Series event. Thank you for my in-person audience, but also my online audience as well. My name is Evan Portier and I'm an educator here at the U.S. National Science Foundation National Center for Atmospheric Research, also known as NSF NCAR. As many of you know, NSF NCAR is a world-leading organization dedicated to studying Earth system science, including the atmosphere, the sun, and the weather, and how these systems are important to building national resiliency. Before we kick off the documentary, I just have a few housekeeping things to take care of. For my in-person audience, we just ask that you are mindful of your snacks as you are enjoying them during the movie and afterwards. For my online audience, feel free to eat as many snacks, drinks, whatever you want to do. We do ask our online audience to answer 2 Slido questions for us. Slido is our virtual platform. For my online audience, you will scroll down and you'll see the Slido platform, and then you'll just click the Join Event button. These 2 questions just help us getting some demographic information, just the number and where your location is. After the screening, we will have a discussion and a Q&A session for both our in-person and virtual or online audience. The discussion and the Q&A will be recorded and available on the NSF NCAR website, so everyone behave yourselves. And with that, it is my pleasure to introduce tonight's Director of Gathered in Darkness, Mr. Daniel Zietlow.
Hi, everyone. Like Evan said, I'm Daniel Zietlow. I was the director of Gathered in Darkness, and I'm really humbled to see so many people in the room, and I know many folks are online too. So thank you so much for being here tonight. This film has been a number of years in the making. So Amir and Sarah reached out to Paul and I, as well as many other folks here at NSF NCAR in 2022. Yeah, 2022. To see if we were interested in collaborating on a large-scale participatory science project that would bring individuals from communities all along the path of totality of the 2024 total solar eclipse, in partnership with not only each other, but then also professional scientists to study the solar corona. And I think my first reaction was like, heck yeah, I want to go see a total solar eclipse. But in seriousness, this is the type of project that I think NSF NCAR really values being a part of. And as a filmmaker, I'm particularly interested in sharing stories about community and helping communities share their own stories. And so I was immediately intrigued by the CATE 2024 mission, just because of how focused on community it really was. And so it was just kind of a natural dovetail into we can produce a film about this. This seems like a good project to do that with. For the story, the science of CATE is really cool. It's really impactful on society. You'll learn a bit about it in the film, but I really wanted to focus on that community that we were creating through this project and really celebrate all the folks that participated as they were preparing for the eclipse, learning how to use the telescopes, and then finally getting to experience the eclipse, some of them for the very first time. And then I was also just really wanted to celebrate kind of this idea of, when all these different communities come together, we all have different experiences, we all have different expertise. If we all have a common goal, we can get some really cool stuff done. So I really wanted to kind of celebrate that message. And so with that, on behalf of the CATE leadership team, I 100% want to thank our 250 plus participants. Literally without all of you, this would not have happened. So thank you so much for your dedication, your enthusiasm, and your commitment to this project. On the production side of things, I definitely want to thank we got Julie Jackson, Ben Fout, and Amy Turner, all from Truce Media. Thank you so much for your guidance, as well as the technical work that you did on the film. I also want to thank Ryan Vashon for all of our conversations, as well as the reviews that you helped with and really just kind of helped me solidify the type of film that I wanted to create. For our funders, thanks to the U.S. National Science Foundation. Thank you so much for recognizing this as a project as well as a film that deserves funding. And also thanks to NASA for supplying additional funding for other parts of the project. And then on Eclipse Day, I couldn't be everywhere. So a big thanks to a team of filmmakers I worked with. So we had Keon Gibson and his team in Dallas. We had Wayne Smith and his team in Cleveland, as well as the Kemp High School team. So thank you so much for all the footage that you provided for the film. And with that, I think we're ready to roll. So again, thank you so much for being here, and I'm really psyched to present the world premiere of Gathered in Darkness. I hope you enjoy it.
A round of applause as we welcome up our panel. Excellent. So I'm going to go just do some brief introductions to our panelists, and then we'll go into a little bit of a conversation, and then afterwards I'll open it up for Q&A. So starting on from our left to our right, I apologize, not Mr. Daniel Zietlow, it's Dr. Daniel Zietlow. He was the Education and Engagement Lead for CATE 2024 and is an educator with NSF NCAR Education, Engagement, and Early Career Development Team, where he focuses on film production and informal engagement. Next up, we have Dr. Paul Bryans. He's a scientist at the High Altitude Observatory at NSF NCAR and was a CATE 2024 scientist. He researches the ways that the sun affects life on Earth using observations from many different telescopes. Next up, we have Dr. Sarah Kovac. She was the project manager of CATE 2024 and is a scientist at the Southwest Research Institute, where she studies the impacts of the sun's expansive solar wind across the inner heliosphere. And last but not certainly least, we have Dr. Amir Caspi. He was the mission lead on CATE 2024 and is the principal scientist at the Southwest Research Institute in Boulder. He studies the sun and the outermost atmosphere, the solar corona, and develops instruments to measure the solar emissions. So, to start us off, I know this project is rooted in community or participatory science. And so I was wondering if you could speak to what was the motivation for CATE 2024 to be a participatory science project and involve the public?
I'll start, but Sarah has, I think, a unique story for this particular kind of event. We didn't come up with this project. Our colleagues in 2017, Matt Penn and Bob Baer and their colleagues, created the original Citizen CATE project. And they showed that being able to do professional level science with community participants was something that was doable and, in fact, very beneficial, not just because of the impact it had on the community, but because it was a way of achieving large projects that would not be easy to do with a bunch of professionals. There aren't that many professionals around that you can just send everywhere. And so we took all of those lessons to heart, and for 2024, we made a next generation project with different kinds of science, different kinds of cameras, and whole new community because the eclipse path was different. And so it allowed us an opportunity to engage with new communities, new people, and achieve a science result that we really couldn't do without the participation of our communities, but also allows us to share the love of science, the love of the universe, of the sun that gives us all of our energy and our light, and allow us to share that with the communities that participated.
Yeah, so from my perspective, I was part of that original 2017 Citizen CATE project. I had the luxury of working with Matt and Bob, who were both fantastic mentors to me for several years throughout my undergrad. And everything kind of came full circle to me to come back and do this again from the professional side, because I benefited so much from that experience as an undergrad, being part of that participatory science, that I went and got my PhD in solar physics, and now I'm here. And so from my perspective, I saw how much of an impact it had when we did it in 2017. And so the goal was, how can we reach more people? How can we do this better? How can we get deeper into different communities? And I think that, all of that kind of gets at one of the cores of the project, which is bringing science to communities that may otherwise never have access to something like this. And I think that that is one of the most beautiful parts of this project, is that we were able to engage with so many people along the path who didn't even know what the corona was, or that the sun had an atmosphere. And that kind of thing, to just kind of see the spark in kids' eyes as they learn these things, was really rewarding. And we saw that in adults too, not just students. And having that times 35 along the path was just really rewarding to see. And as Amir mentioned, it's just not feasible for professionals. And also, everybody experiences totality along the path, right? It doesn't discriminate. We all see more or less the same thing. We all experience the same temperature change in the same environment that we're in. And so bringing a community together over a big event like this really goes a long way in kind of building relationships with those communities.
Excellent.
Can I just add
Yeah.
one point
Oh,
to this?
go for it. Yeah, Paul.
I think it's important is that over the last couple of decades, I feel like there's a trend in this country especially, but around the world, to kind of look on science with skepticism, and scientists as some sort of elites that live in an ivory tower. And I think something like this really is great at connecting the public with real professional scientists and showing them that we are normal-ish. And so, and I think it's much more powerful when they are, I think it's much more powerful when they are,
Really important message.
yeah, when they're doing it with you, right? They're not, we're not just talking at them. They are learning at the same time. They are doing the same work that we do. I think that's a powerful message to send.
Yeah, I mean, completely agree. Yeah, that ability kind of to break down that barrier between science or scientists and the public is great. And so you had a bunch of these community groups collect all of this science. And so I'm wondering, can you speak to what kind of questions and what kind of answers can you get from the science that was collected through this project?
Guess I'll kick it off. I think you heard some of it in the documentary. The sun's corona, the outermost atmosphere, is 100 or a few hundred times hotter than the surface underneath. The surface of the sun's a few thousand degrees. The surface of the corona is millions of degrees. We're still trying to understand exactly how that energy gets into the corona to heat it to that high a level. There are energetic events that happen in the corona. The solar wind, this constant stream of particles, flows out from the corona. We don't exactly know how that stream of particles is born and where, and how it gets accelerated out, where it eventually starts to impact humans and human assets and our planet. We want to understand the very most energetic events, the biggest explosions in the solar system, solar flares, and the associated coronal mass ejections, where these release the energy of 1 billion atom bombs going off in the span of just a few minutes. And they release billions of tons of particles that go out into the interplanetary space, where they pose a danger to spacecraft, to humans. This is really important as we try to make our way back to the moon. We try to make our way to Mars and beyond. We need to understand these events. We need to be able to predict them and understand their effects. And these kinds of studies are the building blocks for building that kind of understanding.
Sure, I can give a more boring answer. So this image that we have up on the screen right now shows the corona in polarization, and that's what the different colors allude to there. When we did this project before in 2017, we had a different detector, a different camera, and we measured only the corona in intensity. So basically just what you would see if you looked up at the sun with your eyes. But this time we measured it in polarization. So this is just the same as if you have your polarized sunglasses and you spin them round, you can see the different polarization states of the corona. And it's cool because it gives you like a rainbow picture instead of just white, but it also tells you something about the corona itself. There's different aspects to it. If you just look in intensity in the light you see, then that comes from a number of different sources. The light from the sun comes out, it scatters off electrons that are out in the corona. It also scatters off dust, interplanetary dust. And one of those is polarized and the other isn't. So if we take polarized images, we can separate the two. And that's important because if we measure the polarized part, then we can learn about what the density, what the temperature is of the outer atmosphere of the sun. And that helps us be able to predict how these coronal mass ejections and eruptions from the sun can impact Earth. The density is important to determine how long it will take before this CME hits an astronaut or a communication satellite.
CME as being coronal mass ejection?
Yes.
Yes, okay. Great, thanks for that kind of science background. And I kind of want to shift gears here and focus on this next question, mostly to you, Dan, because you have this unique background as both being rooted in science, but also being a filmmaker. And so I'm wondering if you could talk to or speak to what is the importance of involving scientists in storytelling and media such as documentaries.
Yeah, I mean, first I just want to acknowledge it. I know it feels like a new concept to kind of unite science and storytelling. It's not. It's a millennia old a concept actually, and there's communities that have been doing this for millennia and are way better at than I am. But I think with storytelling, so you have your key message that you want to communicate. You have your main characters. You have events and kind of details that are driving those characters to go on their journey. But all of that, is the foundational to all of that is really kind of empathy and understanding your audience and their needs and their interests. And so, when I'm in pre-production, some of the first questions I'm asking myself are, who am I telling this story for? What are their questions that they might have about the topic that I'm talking about? What are their past experiences with that topic? Am I even the right person to be telling this story? And if I'm not, who do I need to go out and partner with maybe? And so I think, as scientists, if we maybe start some of our developing our projects, maybe developing some of our questions with those kind of storytelling development elements in mind, we can really start to ask some pretty cool questions and kind of work with community to answer them. I think from a documentary film perspective, with the proliferation of digital media nowadays, it's a very attractive way to engage with a very broad audience. And I don't want to say easily, but kind of easier, right, than maybe having folks come up here to the Mesa Lab, for instance, to talk to our scientists. It's also, since storytelling is kind of grounded in emotion, it's a way to ask our audiences to kind of emotionally connect with our science and the work that we're doing here. And then in many ways too, it's, science can sometimes feel inaccessible. And so video is kind of one way that we can maybe virtually bring folks into this world, right? Like I said, maybe not everybody has a chance to get up here to the Mesa Lab here in Boulder, or if we're on an Arctic field campaign, for instance. So video can kind of invite folks into these spaces. So I feel like that was a really long way to kind of say that telling stories through film and through video are kind of, it's a really great way to ask audiences to emotionally connect with our work and kind of see their kind of day-to-day connections of the work that we do.
Wonderful. Yeah, I really, really like that whole just concept of story and the characters. And speaking of characters, I mean, there's got to be, just logistics and project management. And so I'm wondering, perhaps Sarah, you can speak to this. What are some of the challenges of capturing totality data in such a short window and coordinating all these teams across the U.S.?
Yeah, funny enough, the totality data is actually the easy part.
Yeah.
The recruitment of the teams and, starting from the top down, we had coordinators who oversaw other coordinators who oversaw local teams. And this was set up in such a way so that no one person became very overburdened or responsible for too many teams. This was a very good lesson learned from 2017 with folks who were in charge of lots and lots and lots of teams. And we wanted to make sure this experience was fun for everybody, and it's not fun if it becomes like micromanagey kind of work, right? And so our coordinators were able to have these smaller groups of teams, and therefore, they built almost like their own little community within that. Recruitment itself, we started with kind of just reaching out to people we kind of maybe knew, or we met at conferences, that kind of thing, very high level. And then once we had our regional folks, it was on them to kind of help us navigate who might be good candidates for state coordinators. And then once we had all of our coordinators, them plus the core team, us here in Boulder, we sent out like an interest form where we put that everywhere we could on the internet, sent it out, multiple types of email threads and that kind of thing. And we had, I think it was 379 applications for 35 teams. And so then it was the core team working with the coordinators, trying to figure out which of these teams, were in the right locations, had the ability to, be able to go out and practice for several times prior to the eclipse, be able to attend our workshops that we had. And we had a minimum of 3 people on each team so that everybody had a particular role. As you saw, many teams were much larger than that. But it was challenging in that some of the areas where we wanted to reach into communities that, we wanted the people who were parts of these teams to look like the community around them. And so while we had a lot of applications, we also had some kind of empty spots along the path where the population isn't very high and there might not be a big, like STEM investment in the area. And so we worked extra hard to find teams, local teams in those areas. We did have a small handful of teams who came from off the path to come to, they were usually partnered with somebody who did live along the path. And so that was one other way we were able to kind of expand our participants. But in general, as long as everyone is excited to do it, people are really great at being able to adapt in their environment, or they would bring something to us and say, hey, I think it would be easier if we did this. And we were like, yeah, that's a great idea. We don't see it from that perspective necessarily as professionals. And so to be able to work with people from all different kinds of backgrounds, I think was a huge benefit to the project in that we had all of these different perspectives, and that really helped us shape things like the procedure and just lots of different logistics for the project. And so there was a lot of work by everybody on the core team, and I want to give a special shout out to our regional and state coordinators because they worked endlessly to reach into their communities to find folks who were interested in doing something like this. And I think it's really just a cumulative effort of, who do you know who knows somebody who knows somebody who knows somebody.
Awesome. I mean, that's incredible to hear that there was over like 350 applications for just these 35 spots. And so in thinking about the project itself, you have these 35 teams across the US. Is there, I don't want to say a stand-up, but is there a community group that made like an especially significant contribution that you would like to speak to or talk about?
From my perspective, I really enjoyed seeing all of the student participants. I can't remember our specific stat, but I believe it's more than half of our teams had some form of student participation from middle school, high school, college. One of the beauties of the project is we gave everybody everything. So you could train from having zero astronomy, never touching a telescope before, which was how I came in 2017. I had no hands-on experience whatsoever. And being able to see that, give that back to more students to be able to spark an interest in a career at the time like I didn't even know was a thing, and to bring that to people, from my perspective, was I think the most rewarding part.
I want to say every team
Yeah.
did a standout job.
Yeah.
And really, I know many of them are watching because my watch has been pinging from their Slack messages. They're all celebrating this event with us virtually. I'm indebted to all of those teams. But really, I think everyone became a family, right? A community, not just within their own communities, but an extended community. And one of the things that I think was really heartening and exciting to see was during we'll call them nationwide practices, everybody went out on the same day and tried to practice that day in preparation for the eclipse. On those days and on the eclipse days, the Slack workspace that we have was blowing up with messages where people were saying, hey, I found a new way of doing this. This would help you. And they were posting that not to gain recognition, but to help all of the other teams that might be running into similar issues that they ran into. Or some people were saying, I'm having trouble doing this. And somebody else from 1,000 miles away would say, oh, here's how you do that. Or make sure you check this thing. And some people were very, very active in that. You know who you are, so thank you very much. But everybody, I think, became a family, a community, even though they were separated by 3,000 miles at some point. But maybe that's a little much. But they were separated by huge space. Some of them have never met in person, may never meet in person, and yet they've interacted. They know each other. They shared experiences. And they shared knowledge. And I think that really is what we were aiming for with this project, on top of the science.
Yes, I guess from the filmmaking perspective. So I mentioned at the beginning that I couldn't be everywhere at once. And so when we were storyboarding, I knew right away that we were going to need to collaborate with filmmakers that are local to the path of totality. And so I mentioned Keon, I had mentioned Wayne. And then I also just reached out to the teams saying like, hey, if you have time during your practices or during the day of the eclipse, like if you could take some photos and videos, that'd be great. Expecting I'd get, a handful of kind of cell phone footage. But then I got a message from Kyle and Billy, the Kemp High School team saying, like, yeah, we got a ton of stuff. You're welcome to use it. And they sent me like a whole hard drive of stuff. So special shout out to them for really going above and beyond just their science duties, collecting all that footage. And I believe we actually have Kemp High School online, and let's see if we can get them to get patched in to talk a bit about their experience.
And just so you know, we're gonna see the crowd with no mic on, and then we're gonna head over to another room so that there's not an echo.
Hey, everyone. Awesome. So I think we're going to talk to Katie, right? If you want to share your experience about being a part of the project.
Yes, we're going to talk to Katie. I'm headed to the theater where she's at now. Can you hear me?
Yeah, we hear you great.
Okay, awesome. So Katie was the one that was interviewed in the documentary during our segment. And she was the lead on getting the telescope and cameras, or getting the camera set up and in the right position, and using the controls and things like that. And on the day of the eclipse, here in Texas, it was very cloudy. We were actually really worried. We didn't actually get to start setting the video camera up until about 45 minutes before total eclipse, before it went dark. And it was about 30 minutes before, and we couldn't get it centered exactly right. 20 minutes before, we're still struggling. We're texting Amir back and forth. What do we do? What do we do? Do we just roll with it? And we kind of went all through the brainstorming, and literally maybe 10 minutes, am I right? 10 minutes before, Katie did something. I don't even know what she did, but yeah, we actually had a plan of how many minutes we needed to just give up. And then all of a sudden I didn't even know it was ready. And then all of a sudden everything was just perfect. And we just got really good videos. And so I wanted to have her have a chance to talk about her experience and with y'all, because she did such a great job. So let me flip the camera around to her. And I think she's already has the question, so I think she's ready to go.
Hi, so my name is Katie, and I'm currently a senior at Kemp High School. And the Citizen CATE project has been one of the most amazing things I've ever been a part of. We come from a small area, and we don't have many opportunities like this. So the fact that something like this just came about was beyond a miracle. We don't have highly funded STEM programs. We don't have things like this thrown at us every day. And one of the most amazing parts of it is that we were able to get our whole community involved. And seeing the impact that just this one project made on our small community was beyond imaginable. And that's what made the project so fun, is that it involved community, teachers, volunteers, everyone working side by side with professionals to make this happen. And it was a lot of trial and error, and it was a lot of long practices that all you wanted to do was lay in your bed. But we still got up every morning and came out there and did our best. And in the end, it paid off because we got some amazing pictures from it. And we all have amazing memories from it too. I mean, we got stuck in the mug. We have Thomas's singing on video, and we have other funny things that happened throughout the whole project that will always be a part of it. But it was just really amazing coming from such a small area that really didn't have much to, being on national television and being a part of the over 40 teams that were able to make it happen. So, yeah.
All right. Do you have follow-up questions?
I don't have any follow-up questions, but I don't know if the audience just can give just a round of applause.
I need to go back. Oh, that audience. Well, thank you so much for including us on this night.
I also just want to mention Katie and her team got interviewed on CNN, so that was what she was talking about with the international TV. And I totally saw that footage, Thomas, of you singing. I just couldn't use it in the film because the music was copywritten. Oh, we got a question back here, Evan. Oh.
Superstar in this project.
Yeah, definitely. We'll see if we can pull up Katie again. But again, just echoing that, it's beautiful story. This project just brought together all these communities, and it was, I don't know about you, so heartwarming to hear that. So yeah, we'll see if we can pull her up again and ask that question. I do want to give our audience.
Back.
Oh, they are back.
What was the question again?
Yeah.
So you've been such a superstar in this project, and to hear you explain it was so inspiring to all of us, I think. I'm wondering, and I bet a lot of other people are wondering, what's next for you? What are you thinking about for your future now, for next year and beyond? In science, perhaps?
I actually am thinking about science. I have given it some thought of possibly pursuing a career in, this kind of science, but I lean towards more the medical side. So I plan to continue my education at the University of Austin, or at the University of Texas in Austin to study biochemistry. So one day I can do stuff like this, but with hopefully, medical research and help impact people that way.
Excellent. Well, thank you so much, Katie and Stephen and the rest of the Kemp High School team. We really appreciate all your contribution on this project. And yeah, I don't know if you wanted to say anything else, Dan, to this group, or.
No, I mean, again, just thank you so much for all the footage. I had a ton of fun reviewing all that footage. It seemed like y'all had a really good time out there, so thanks again.
Excellent. Well, folks, we're going to move into our Q&A session here. How this is going to work, if you're an in-person audience and you want to ask a question, just go ahead, raise your hand. We've got two great volunteers that are going to shuttle microphones back and forth. If you are online, you're going to use that Slido platform. Again, it's just below the screen, the player, and go ahead and switch on to the Q&A tab and go ahead and you can input your questions. So with that, do we have any questions from the audience? Oh, I've seen one hand. Come on.
Thank you. It's a wonderful project, but I had just a nuts and bolts kind of question. They all had the same telescope and equipment. Who funded it?
You say nuts and bolts, which is interesting because some of the nuts and bolts fell out during shipping. But yes, everyone had the same equipment. That was one of the things that the 2017 team had pioneered, and we adopted that strategy because that means that with the same equipment, the same training, we would have as close to a uniform data set as we can get. NSF funded all of the equipment. They funded a lot of the labor. They funded the participation of our community teams as well to try and break down the barriers of participation. And then NASA provided a lot of funding for the professional science and all of the software that we had to write, the data taking, and all of that is in fact still ongoing.
I'm going to ask a quick question. I may not have been paying attention closely enough, but what does CATE stand for?
So because we were kind of building off the backbone of the CATE 2017 project, we stuck with that name. It stands originally for the Citizen Continental America Telescopic Eclipse Experiment, the Citizen CATE experiment, which is why we go by CATE 2024.
Excellent. We're going to pull up one of our online questions. Dramatic pause.
That's dramatic pause.
Excellent. So this question is, how do I obtain a copy of my astronomy club? What tracking mounts were used in most of the video? I was in Copperas Cove, Texas for this eclipse, but it was clouded out through most of totality. Thanks, Steve.
If the question is asking about a copy of the documentary, I will leave that to Dan to answer in just a minute. If it's a question of how do you get your own equipment, the equipment list is actually going to be published very soon. We have a paper that's currently going through review that Sarah wrote that explains the project and has the full equipment list. The tracking mount specifically was an iOptron Gem 28 tracking mount. But all of that stuff will be available shortly after the journal reviews it and it goes through publication. It'll be available to anybody to read.
Yeah, and for the documentary, so I mean, first we're working on distribution through PBS. We have a handful of local stations that are interested in it, and we're waiting to hear back from national to see if they'll pick it up and start distributing it as well. And then for kind of school and community groups, there is a request link on our website now. So if you just go to our EDC website, so edc.ucar.edu, you'll be able to navigate to the request a screening link there. And then for individuals, we're still working on that. I'll let you know soon.
Excellent. Do we have another in-person? Go for it.
So you had 20, whatever it was, how many different locations, 35 or so, where you were gathering this data. And you were munching all this data together. At any one location, you were seeing totality, and you were seeing the same coronas and the same kind of data coming back from each one. What was the advantage, if there was any indeed, of actually taking all of that information, munching it together, and coming up with kind of some new science from it?
I think this is a good point maybe to bring up the movie because so each depending on where you were along totality path, you had 2 or 3 minutes of totality. But when we stitch those 35 sites together, then we get an hour's worth of data approximately. So that's 2 or 3 minutes is not really long enough to see any changes in the corona over that period of time, but 60 minutes is. So if you watch this movie, you can see some things evolving over time.
Just an excerpt.
Yeah, we have not got to the point yet where we've made the full 60-minute movie. There's still a lot of image processing needs to be done. So,
Excellent. Great question. We're going to take another online question. In San Antonio, we had cloud cover and drove 90 miles out of town for the eclipse. Did any of your teams relocate at the last minute due to cloud cover?
So this was something that we talked about with our teams prior to Eclipse Day. In general, no. Our teams had locations that they were meant to be at, that many of them had planned for months to be at, made special arrangements to be at. And if teams veered too far from that location, we would no longer have continuous coverage of the eclipse. Additionally, the equipment is not something that can easily be thrown together in like 15 minutes and get on the sun and get good images. So we stuck with the approach of, they were comfortable with where they were at. We had a handful of mobile teams who I know did, who were not part of our core 35 teams, but we had additional outreach and engagement sites. And I know of at least 2 teams, I think, who made, a few miles of detour to be in a slightly better location. But due to the nature of the project and looking for that continuity in our, end video, we did have our teams pretty much stay put. And I believe we only had about 4 teams that were that were rained on, essentially. So unfortunately, that is, myself included, unfortunately, that is, the weather is just something we can't control. We have to let that go. But we did let teams, be comfortable with where they were. And so for lots of reasons, we asked them to stay put.
We'll take
Sorry,
go
just
for it.
one addendum. That's part of the reason we had so many teams. In reality, it would only have taken about 17 to cover everything, but that assumes everything goes perfectly. The reason we had 35 is that every team was covered by their neighbors. And so if one team had clouds, or if one team had a telescope break or something like that, as long as the other 2 teams didn't have clouds and equipment failure, we would still have continuous data. Now, it turns out the clouds were a little more pervasive than we hoped, but we, as Sarah said, I think we had 85% of our sites got some or all of totality.
You have another in-person question. Go for it.
So once you have that consolidated 60-minute Corona video, are you going to release that?
All of the data will be available to the public. It is taxpayer funded. It is therefore taxpayer owned. And so, yes, all of the data will be publicly available. It will be released, not just for scientists, but for our communities to use. We're hoping that the communities who participated in this will continue to engage with that data, whether it's for science or for art or some other exploratory function, but it will be available for everybody worldwide. So stay tuned and you'll be able to access all of that.
Wonderful. And I still think we have online questions, so we'll go ahead and pull up. It would be great to see graphs of ambient lighting level as a function of time/obscuration percentage during passage of umbra. Seems kind of a sciencey question, if I've ever heard one myself.
Paul, do you want to take that one?
yes, I agree.
We don't have that particular data.
Yeah, gotcha.
I say you can. Graphs of that are nice, but I think the beauty of the eclipse is experiencing that graph personally. Right, when you're there, you feel that darkness, you feel the temperature change. So that's what I love most about the eclipse. I mean, the science is fine, right? But it is real. It's awesome to be there and experience.
Actually, one brief follow-up to that. People talk about, I was at 99% totality, therefore, I was in the eclipse. I heard somebody in the audience shout no immediately after I said that. So just to remind you, what you heard in the documentary, Paul mentioned the surface of the sun is 1 million times brighter than the corona. that means that at 99% totality, it is still 100 times brighter. 1,000? I'm not even doing the math correct. 10,000 times. I can't do math anymore because I have a PhD. But no, at 99% totality, it is still 10,000 times, sorry, at 99% partial eclipse, it is 10,000 times brighter. At 99.9, it's still 1,000 times brighter. So really, you must be in totality to experience that. And it is, a lot of people say this, it sounds like it's a cliche. It literally is like the difference between night and day.
I just want to clarify, there is no such thing as 99% totality. You're either in totality or you're not.
Excellent. We've got a question in the back.
I know for Dr. Kovac, since you were involved with the 2017 eclipse, and then in relation to what happened with the 2024 eclipse, what are some like hopes or aspirations for the upcoming eclipses in like 20 years or so? Like, what are your aspirations for those projects?
I'm still recovering from this one. No, that's a great question. So the U.S. doesn't get another total, sorry, the continental U.S. doesn't get another total for 20 years, I think it is. There are, of course, eclipses very frequently between now and then. I think when I was writing the paper, I think it's 13 eclipses. So the next one that is coming up is in, it goes over both Iceland and Spain. And so I know I've already spoken with some of our state coordinators who just have plans to go there anyway because they're people who chase eclipses. And so they're going to take their equipment with them and take some images. In terms of doing things more large scale, like having, a couple of dozen teams, I think that it's something that would be really, really cool to do. I think it takes a different strain of coordination when you're talking about international partnerships like that. But I think, between the groundwork that was laid in 2017 and then being able to do it again with, different tweaks and different upgrades and different changes, it kind of paves the way that if other people in other countries want to do this, we kind of have this groundwork and we've proven that it works. So Australia gets something like 3 eclipses in 5 years. So if anyone's over there, it's definitely something that can be applied to, any other eclipse. You just have to get the right group of people together to kind of coordinate everything.
Excellent. And we're going to go with an online question, and we're going to have maybe 2 more after this. Nice work, Dan. Awesome film. What are your plans for 26 and 28?
Thanks, William. I don't know. Depends on funding, I guess. I mean, that's the honest answer. No, I mean, I know here at NSF NCAR, nothing's funded, so don't hold me to this. Some plans to maybe do something for the 2026 eclipse, so we might be able to do something around there. And we haven't thought quite to 2028 because we have about 10 other field projects on our plate before then. But yeah, hopefully we can do something.
Awesome. We're going to go for one last question in the audience, and if you're in person, the panels will stick around and they can answer your questions. Let's go for it.
I was just wondering what kind of solar physics you have gotten out of these data so far.
I would say these data so far is very limited because we are still trying to calibrate the data properly. So actual solar scientific results, we're not there yet.
Just to give you an idea of scope, there are over 47,000 individual images of totality from all of the sites that we're able to see totality. There are 86,000 total images that include all of the calibration data before and after. So this is over 2 terabytes of data. As you can imagine, all of the 40 different telescopes were oriented slightly differently. Everyone had a slight different angle to their camera. Everyone had slightly different sky conditions. Everyone had slightly different observing conditions. And so we are trying to unify all of that data, make it a uniform data set, get everything co-aligned to each other. So there are a lot of challenges. Sarah is leading the development of that processing pipeline. And so all of what you saw there is sort of the beta testing of that particular pipeline. But you can imagine all of the work that goes into it. So even now, over a year after the eclipse, we're still working on that, but that should be done in the next few months. And then you can look forward to a first results paper, hopefully later this year.
Excellent. If we still have questions in our audience, you can go ahead and ask them afterwards. Right now, let's just go ahead and give them a round of applause.
Evan, if I may, I
Yes.
do want to make
Yes.
sure that that round of applause is also for not only all of our community teams that participated and our coordinators and all of our tireless team members, both professional and community members, but also for NSF and NASA for agreeing to fund this amazing project and help get the community and the training out to these communities that hopefully will have a lasting impact forever.
Excellent. Thank you. Alrighty. Thank you everyone for attending this special premiere as part of the Explorer series. I know a lot of you getting up. Just hang tight with me 1 second here. If you are 18 years or older, which I see a lot of folks you are, please take a moment to fill out our 3 to 5 minute anonymous survey to help us better understand the impact of this program and how we can improve for our next event. The survey will close on next Monday, April 28th. You can find the survey by scanning the QR code right up there, and you can also ask a staff member if you'd like to take the survey using one of our tablet computers. If you would like to request a screening of the documentary or know anyone who wants to, please consult us and we'll be happy to send that request. We hope to see you all again in person or online on May 14th at 7 p.m. We're getting started a little later now for our next Explorer Series event on the history of urban air quality with Dr. Kelly Barsanti. If you're interested in more NSF NCAR Explorer Series events, check out our website for upcoming lectures and conversations and to view past recordings. And last but not least, my in-person audience, please take any leftover food or trash as you exit the theater. With that, thank you everyone. Thank you online audience. Thank you in person. Have a great night.